Okay, hi everyone. So we're going to keep on going with Unit 9, Lesson 3, the intersection of a line with a plane in 3 space. So what's going to be important here is we're going to be figuring out and discussing what happens between the intersections of a line and a plane. So that's going to be the key idea here. And as you can see, there's 3 different cases. We have m dot n is equal to 0. So here we have no intersection. The line is parallel to the plane. So then we can actually draw our vectors on this diagram here. So n is always going to be perpendicular to the plane. So we have n like here. And then we have another vector m, which is on this line, and it's going this way. And it's important to note that over here, the angle is 90 degrees. So that's the first case. Then we have the second case, is the intersection in one point. So the line and the plane intersect at one point, so m dot n is not equal to 0. So we can do the same thing and draw the vectors. So we can have m here, so that goes on the line. And then we have n, which is perpendicular to the plane. So that's the second case. Now finally the third case is when the plane lies with the line. So the line is actually in the plane, so the dot product m dot n is equal to 0. So we can also draw again n and m vectors. So here's n, it's perpendicular to the plane, and then m is on the line. So these are the 3 cases that we'll talk about, and here's some algebraic rules. So the first one is substitute the parametric equations of the line in the scalar form of the equation of the plane. Then solve this equation for the parameter. And the second one is always be aware of the relationship between the direction vector of the line and the normal of the plane. So we'll talk about this, and you'll see how it works once we do some of the examples. So we'll start with the first example here. So the first one is saying, find the points of intersection of the following lines and planes. So we have the line and then the plane. So I'll just start by rewriting this. So we can write this as in this form. So 4, 2, 6 plus t, so that's 1, negative 2, and 3. Sorry, that's our r vector. So I'm going to just put r. Go. Okay. So just put it into this form so it'll be a little bit easier to see. So the first vector is m, and that's from this vector here, 1, negative 2, 3. And then we can also get the second vector n from the plane. So there's the coefficients here, 2, 5, and negative 1. So that's where we're going to get that vector from. Okay, so for this, if you actually do the dot product, you'll see that when you do the dot product of m dot n, it's actually not equal to 0, which means there'll be one solution. So we'll write it like this. It's not equal to 0. Now, what we're going to do is sub in the values we have from the line into the plane. So here we have 2, and then we get the x from this line, so it's going to be 4 plus t plus 5, and then the y value is 2 minus 2t minus z is 6 plus 3t minus 34, and that's equal to 0. So then we're going to just simplify this, and we're going to get 8 plus 2t plus 10 minus 10t minus 6 minus 3t minus 34 is equal to 0. From this, we'll simplify it further. We'll get negative 11t is equal to 22. And then here we'll get that t is equal to negative 2. So now we got this value t is equal to negative 2. We're going to actually sub it back into the equation of the line, and then that'll give us the point of intersection. So I'm going to just write a note here. Sub t is equal to 2 back into the equation of the line. Just going to move this over here. Okay, so here we're going to get x is equal to 4 minus 2, which is equal to 2. Y is equal to 2 minus 2 times negative 2 is equal to 6. And then the final one, z is equal to 6 plus 3 is negative 2. And then here we're going to get 0. So this is actually the point that the line and the plane intersect. So therefore, the point of intersection is at 2, 6, 0. And we'll actually graph this just so you can get a visual representation of it. So we have the plane 2x plus 5y minus z minus 34 is equal to 0. And then we have the line 4, 2, 6 plus t 1, negative 2, and 3. So here it is, and you can see the line is in black and then the plane is in blue, and you'll see that it actually only intersects at this one point right here. That's the point of intersection. Okay, so we'll move on to the next question. So here we have another vector. It's the vector equation with the plane, and we're going to see if it's going to intersect anywhere. So we're going to start with the vector m, and that's equal to 2, 1, and negative, 2, 1, and positive 3. No, sorry, that's my mistake. Actually, it's 2, 1, negative 3, and then that comes from the vector equation. 3. And then we're going to do the same thing. We're going to get the vector from the plane. So n, that's going to be equal to 2, 5, 3. So what you can do is you can do the dot product, m dot n, and you'll see that it's actually 0. Another way to do this, which is maybe a little bit easier, is simply changing this into the other form, the parametric equation, and then plugging it back into the plane and solving. So here, I'll just put it back into this other equation so it's easier to see. So x is equal to 3 plus 2t. Y is equal to negative 2 plus t. And then z is equal to negative 3t. So now we're just going to plug this into the back into the equation of the plane. So we're going to get 2 multiplied by 3 plus 2t plus 5 multiplied by negative 2 plus t plus 3 multiplied by negative 3t plus 4 is equal to 0. So now the next step, we're just going to simplify this further. So we're going to get 6 plus 4t minus 10 plus 5t minus 9t plus 4 is equal to 0. From this, it will simplify further to 0t is equal to 0. So what does this actually mean, 0t is equal to 0? That means actually that the intersection is the entire line. So the line is parallel with the plane, so they're actually on top of each other. So here I'll write therefore the intersection is the entire line. Okay, so now we'll actually graph this so you can see what's happening. Okay, so this is the line, and then the plane is 2x plus 5y plus 3z plus 4 is equal to 0. Here you'll see that the the line is actually on the plane, so there's infinitely many solutions to this one. Okay, so one other note here that I actually want to write is that m dot n is equal to 0. You can actually plug in the point 3, -2, 0 into the plane, and you'll see that it'll actually be 0. So let's actually do that. So we'll get 2 multiplied by 3 plus 5 multiplied by -2 plus 0 plus 4. So we're actually going to get that that's equal to 0. So for this, the left side is equal to the right side. This was just another way to look at this. Okay, so the next one, we have the vector and then the plane. So it's going to be the same procedure as the last one. I'm just going to change this form back into the parametric so that it's easier to see. So we'll have x is equal to 2 plus 3t, y is equal to 1 plus t, and z is equal to 3 plus 2t. So now what I'm going to do is just plug this back into the equation of the plane. So we have 2 times 2 plus 3t plus 4 times 1 plus t minus 5 multiplied by 3 plus 2t plus 6 is equal to 0. Now we're just going to keep simplifying it again like we did the previous time. 4 plus 6t plus 4 plus 4t minus 15 minus 10t plus 6 is equal to 0. Simplifying this further, we're going to get 0t minus 1 is equal to 0. So here we get 0t. Well, we're going to bring -1 over to the other side, so 0t is equal to 1, but 0t is never going to be equal to 1. So when you have 0t is equal to 1, that means any number multiplied by 0 is always going to be 0, which means it's never going to equal to -1. That means there's no solution, so it's inconsistent. So we'll actually graph this so you can understand that the line and the plane are never going to intersect. So we have the line okay, so there's the line, and then we're going to have the plane. Okay. This might be hard to see, but you can kind of see from here. So this actually, the plane is here, this like dotted line, and then there's X, that's the line. Sorry, the blue is the plane. This X here with that, it's black, that's the line. You'll see that they actually never intersect. So there's never going to be any solution for this one. Okay, so this next question says, where does the plane 2x minus 3y minus 4z minus 3 equal to 0 intersect the x-axis? So here, when we have the x-axis, we can just make a note here. So x-axis. This is you can write it as like this: x comma 0 comma 0. So then that's actually going to be the direction vector. So we'll write it like this. R is equal to 0, 0, 0 plus t, and I'm going to replace the x with a 1. So now the next step for this, I'm going to put it back into the parametric equation. So we're going to get x is equal to t, y is equal to 0, and z is equal to 0. So I get these because it's going to intersect the x-axis. So y and z are going to be 0. It's just x that we're not sure about. So we're going to call that with the parameter t. So what we're going to actually do is just plug in these values back into the equation of the plane, and we're going to solve for t. So we're going to get 2t minus 3 times 0 minus 4 times 0 minus 3 is equal to 0. So that'll simplify to 2t minus 3 is equal to 0. Furthermore, we're going to bring 3 to the other side and divide by 2. So t is equal to 3 over 2. So then therefore, we're going to put our therefore statement. So now we know at what point it's going to intersect the x-axis at. So we're going to write the plane intersects the x-axis at 3 over 2, 0, 0. Okay, so from here, let's actually graph this to see that this actually does intersect at 3 over 2, 0, 0. So here we're going to have the point 3 over 2, 0, 0, and then the plane, which is 2x minus 3y minus 4z minus 3 is equal to 0. So there's the point here, point A, and then this red line is the x-axis. So at exactly that point, 3 over 2, that's 1.5, that's where on the x-axis the plane intersects. Okay, and then finally, this is the last question. Where does the line r is equal to 5, 2, 0 plus t3, 4, -1 intersect the xy plane? So it's important to consider this here. What does it mean, the xy plane? How do you know what variable is going to be equal to 0 here? So here I'm just going to write a chart that'll be helpful to remember this. So when we have the xy plane, that means that z is equal to 0. And then we have the xz plane, y is equal to 0. And then finally, the yz plane, x is equal to 0. So basically, the plane that's not actually, like the variable that's not here is what's going to be equal to 0. So here, xy, what's missing is z. So z is equal to 0. Here we have xz, y is going to be equal to 0. Y is not actually here. And then yz plane, x is equal to 0. So it's whatever variable is missing, and then that's equal to 0. So what we're going to do is change this back into the parametric equation. It'll be easier to understand this. So we're going to have x is equal to 5 plus 3t. The next one, y is equal to 2 plus 4t. And then finally, z is equal to 0 minus 1t. Okay, so now the next step here, when it's talking intersect the xy plane, so from here what we talked about, the xy plane, z is going to be equal to 0. So let's go back here and set z equal to 0 and solve for t. So I'll just write this again. Z is equal to 0 minus 1t. So here's where we're going to substitute this. So 0 is equal to 0 minus 1t. So here we're going to get that t is equal to 0. Okay, so now we have t is equal to 0. Now let's plug this back into every single equation we have here to find the point, that corresponding x, y, and z value. So here we have x is equal to 5 plus 3, 0. So here we're just going to put 0, and then that's going to be equal to 5. Now we're going to do the same thing here. Y is equal to 2 plus 4, 0. And we're going to get 2. And then finally with z, we have z is equal to, well, we already have this one, but I'll just write it again. Z is equal to 0 minus 1, 0. And that's equal to 0. So, therefore, the point of intersection is at 5, 2, 0. So let's just graph this to see if we're going to understand this. So here we have 5, 2, 0. There's the point, and then the vector equation, which is 5, 2, 0 plus t 3, 4, -1. then the for the xy plane, z is equal to 0. So there we go. So the line, so here's the line, this is the point, and then the plane. So this is actually where it intersects the xy plane. Okay, so this was the lesson. Try some of these questions out in the textbook problems as well. Feel free to email us at any point if you have any questions or need help with anything. Feel free to message us. Okay, have a good day.